A new Wordle puzzle is online. Click on the link to play.
Listening to the following video may give you clues. Please like and share the videos.
How Mercedes hopes to gain from its extreme F1 front wing. The idea of making a Mercedes-Benz front wing as extreme as the F1 car's rear swoosh is not entirely new.
Red Bull's high rear wing has been an example. However, the Mercedes CLS class project has been plagued with porpoising impacts.
To counter these impacts, Mercedes has changed the geometry of its front wing's top flap. They have also upgraded the external edge of the front wing, which has been previously trimmed.
Red Bull's high rear wing. The new B-Phone front wing has been compared to the one that Ferrari used in 2017.
Both wing designs have extreme, aerodynamic shapes. The RB18 uses 4 panels, the top 2 of which are steeper than the bottom, making it look like the front wing is actually in 2 parts.
In addition, it seems like the nose of the Ferrari is less tapered than that of the Mercedes, possibly due to the fact that its top panel is flattened. New design is a result of a complex aerodynamics study.
Mercedes is one of the first teams to exacerbate the Coanda effect of bodywork. It has narrowed the sidepods and created an air chute.
This design is legal because the air flows from the upper part of the wing to the upper edge of the diffuser and floor. Mercedes' aerodynamics study is a result of extensive communication with officials and extensive planning.
The new regulations have forced the teams to rethink aerodynamics, and the F1 front wing is no exception. The car's wing will help improve its downforce and performance, as long as it doesn't get in the way of the car's airflow.
While it doesn't have the same effect on phone cars as an front wing, it will certainly boost its aerodynamics to improve aerodynamics. Mercedes has also reprofiled the car's floor and changed the geometry of the bodyboard area.
The modifications have worked well for Hamilton at Silverstone and the Hungaroring, but are likely to be their final upgrades for the 2019 season. Red Bull, meanwhile, is pursuing a more aggressive strategy and has already made modifications to its wing at the Dutch and Belgian GPs.
The team's driver Christian Horner has stated ahead of the races that he is not giving up on the development of 2021 wing's new lower rear spoiler is more conventional and uses a traditional main plane design with a flat frontage, as opposed to a spoon sheet design that some competitors have adopted.
Refinements have also been made to the radial wing elements. The upper element's chord length was decreased near the outer end of the wing to reduce drag.
It also reduces the weight of the car. Mercedes low rake car.
The W13 will feature a new front wing, and the rear wing will have a different configuration. Mercedes hopes this will reduce drag, which will improve the car's overall efficiency.
The front wing has been altered, with the upper flap being flatter and less wavy than previous versions. In addition, Pirelli has been working to make their tires less susceptible to overheating.
These changes will have a significant impact on the car's overall efficiency, which will be a key factor in the 2021 Formula One season. In addition to modifying the front wing, Mercedes also made changes to the rear spoiler.
The new rear spoiler has a flat frontage, while other competitors have opted for spoon-shaped designs. The radial wing elements were also redesigned.
The upper element's chord length was reduced towards its outer end to reduce drag and load. The winglet is the most visible part of the car, and the sidepods are a key component of the aerodynamics.
Another big change in phone is the new rules on aerodynamics. This year's rules included lower front wings and taller rear wings, which resulted in cleaner bodywork.
Perhaps the most interesting change was the introduction of movable aerodynamics. The driver can now adjust the front wing from the cockpit.
With the new rules, Mercedes hopes to increase its speed even further. While there have been numerous controversies regarding aerodynamics and the new wing, the changes are based on thorough research carried out in-house.
The team's development of the W13 is not complete yet. It will have more time in practice to experiment with various configurations and setups.
It's also reportedly sensitive to underbody airflow. While it's incredibly effective in creating downforce, the problem has been that the floor of the car has been sucked into the air, and this is wasting valuable performance.
It will be interesting to see how Mercedes reverts to its original plan to improve the front wing. The design is also crucial in terms of aerodynamics.
Phone cars need clean airflow to work at optimum levels and generate downforce. The previous style of cars relied on flat undersides and had a tendency to run low.
The ground effect design pushes the front wheel wake outward, allowing cars to corner much faster. This could improve downforce and help cars overtake other cars.
Movable aerodynamics. In a bid to improve their car's aerodynamic performance and curb porpoising, Mercedes has been experimenting with a low-drag rear wing and extreme end plates.
These new developments hint at what the team plans for the future of the car. Porpoising has plagued the Mercedes since the start of this campaign.
Mercedes aims to improve this behavior by driving lower to the ground and controlling the car's behavior. While the new cars are more aerodynamically efficient, they still suffer from a lack of downforce when they are close to the front of the field.
That is because the car's front wing generates downforce differently. These changes will give Mercedes' car better performance when the car is close to the car in front.
The goal is to create a more balanced car that will allow drivers to push harder even when cars are close. Extreme phone front wing has become a controversial issue, with many teams considering removing the aerodynamic component in favor of an aerodynamic redesign.
The design isn't perfect, but it does give the car better aerodynamics. Mercedes aimed to make the car as aerodynamically efficient as possible, and their new wing is far different from other cars.
However, while the FIA has been demanding more aerodynamic regulation, they have found a way to experiment with the design. New rules have changed the aerodynamics of phone cars.
Some have introduced full-width, minimalist front wings at the 1968 Belgian Grand Prix. Early experiments with movable wings produced spectacular crashes and resulted in restrictions on their size and location.
The regulations were changed in the 1970s and eventually evolved into the similar rules used today. If you're looking for more information on Mercedes' new wing, check out the new rules.
Although barge boards have been banned from the new Formula One cars, the aerodynamic shapes of the front wings are becoming more strict. However, this hasn't completely solved the problem of messy airflow as it disrupts the aerodynamic surfaces further rear on the car.
To solve this problem, the teams have experimented with various sidepod designs, but they are still facing a major challenge: drag reduction strategy.
If you are a die-hard fan of Formula One, then you will know all about the extreme strategies that the team uses to lower the drag on their cars. The most controversial of these tactics, DRS, was banned from the sport in 2013.
It used a rear wing flap which opened up to reduce the aerodynamic drag on the car, which in turn allowed it to accelerate in a straight line and make overtaking easier. Formula One teams are known for pushing the boundaries of automotive design and have spent millions of dollars developing their aerodynamics systems.
This approach is known as the marginal gain strategy because it focuses on details that are seemingly inconsequential, but can make a big difference. Mercedes has spent millions of dollars working on this strategy, and its engineers have made significant improvements.
Compared to other Formula One teams, the wing drag reduction strategy has made it possible to increase downforce by as much as 10. As a result, Lewis Hamilton has been disqualified from qualifying and will start the Brazilian Grand Prix sprint race from the back.
Meanwhile, Max Verstappen has been fined €50,000 for tampering with the rear wing, although he did not touch the part when testing. The engineers are tasked with regulating the airflow in the rear of the car as the front wing opens and closes.
The extreme front wing drag reduction strategy that Mercedes has announced this season is based on its new aerodynamics philosophy. The car's front wing is the most regulated part of a Formula One car, with the size and flexibility regulated by the FIA.
The front wing is an important component of the car's aerodynamics, and it is a part that has undergone extensive research. The optimum shape of the front wing is dictated by the influence it has on the flow to the underbody and rear wing.
Because the front wing contributes a high proportion of the car's downforce, all of the shapes are three-dimensional and have varying shapes inboard and outboard. Nevertheless, the optimum front wing design will require a high degree of aerodynamic testing.